All right, hi students, welcome to the virtual classroom. Today we're going to look at determining the equation of a quadratic function, being given a piece of information or a couple pieces of information. Okay, so this starts on your page 70 of your note package, if you're using that still. And we're going to be looking at it with the vertex form for a quadratic function. So in that y equals a times x minus p squared plus q format. Okay, so if you were to be given a parabola like this, and you knew that its vertex happened at when x was 3 and when y was 2, you know a bunch of information already about that vertex or about that quadratic formula. You know the range starts is a minimum range, so y has to be greater than or equal to 2. You know the domain is x is all real numbers. You know the vertex is at 3, 2, and that means you know almost the whole equation because y equals because this is vertex form and y equals x minus p squared plus q. So if we know what the x value of the vertex is, we can put that in for p. And if we know what the y value of the vertex is, we can put that in for q. What we don't know is a. We don't know the amount of compression or expansion. And we would need another piece of information to figure that out. So let's look at some examples where they've given us the information and we just need to put this in. Okay. So it says the vertex is 1, -3, and a, the compression factor, is 2. So remember that the vertex is given us as an xy, but it also gives us our pq. They're just really different letters for the same thing. And the reason we don't use x and y in the vertex formula is that would get really confusing because it would be x minus x plus y. It would be weird. So they use different letters to represent the x and y coordinates of the vertex. So we're just going to plunk these numbers in to this equation. So y equals a. A is given to us here. It is 2. X minus p, and p is given to us with the x coordinate of the vertex, so it is x minus 1 squared plus q. And our q is given to us with the y coordinate of our vertex, so it's plus -3. Now we can simplify this. I didn't really give myself very much room to write this. I'm going to improvise here. We can simplify this because when you plus a negative number, it just becomes a minus. So y equals 2, x minus 1 squared minus 3. Right? Pause the video here and try B and C. Right. So this next one we're going to do as well. We're going to go y equals a. So a is given to us as -3. X minus p, and the p value is given to us with the, again, with the x coordinate of the vertex. So it is -2 squared plus q, which is 5. And now, of course, oops, there's supposed to be a double bracket there. We can simplify. Y equals -3. X minus -2 is x plus 2 squared plus 5. And again, pause the video if you haven't already done so and try C. Okay. So y equals a, so a is -1/3, x minus the x coordinate of our vertex, so that's p, so it's -7, plus q, which is -9. That's a plus there. Doesn't look like it, but it is. Right, so now we can simplify. Y equals -1/3 times x minus -7 is x plus 7 squared. That again is a plus, and again, doesn't look like it. And then plus -9 becomes -9. And there's our equation for that parabola. So we can go further with example 2. So it says, write an equation for a parabola given congruent equation, vertex, and direction of opening. Note, being given the equation of a congruent parabola gives us the value for A. Congruent means it's the same shape. It might be somewhere else on the Cartesian plane, but it has the same shape. It has the same level or factor of compression or expansion. The rest of the equation for the congruent parabola, we don't care about. So if you look at example 2a here, it says it's congruent to y equals 2x squared. We only care about this part here. We care about its compression. That's the only piece of information we need from that. So that means a equals 2. And then of course we've been given the vertex. And now we're kind of right back to where we were in the previous example. We're going to put this into equation. Y equals a. So we get the a value from that congruent formula. So a equals 2. X minus the x coordinate of our vertex, which is p, plus q, which is the y coordinate of our vertex, 1. And now we have written the equation for a parabola that has that vertex at 5, 1 and is congruent to the parabola that has the equation y equals 2x squared. So pause the video here and try the next one. Okay. So for the next one, it also gives us a vertex and it gives us a congruent formula. And again, for the congruent formula, we only care about the a value. The rest of it doesn't help us at all. So then we're going to write our equation, y equals a. So we get the a value from the a value of the congruent parabola. So it's 1/4. It's going to be x minus -7. So it's x plus 7 squared. And it's going to be plus q. So plus -3 becomes -3. What happens if it doesn't give us a nicely presented to you or nicely given to you in a congruent formula? We can still find it, but we need to have pieces of information. We need to have the vertex, and we need to have at least one other point that exists on the parabola. It doesn't matter which point this is, it just has to be on the parabola. And we don't actually need more than one. So if you're given multiple ones, you would just pick one. Okay. This is the section you're going to come back to for the rockets assignment, because this is going to help you create a formula for the parabolic motion of your rocket. So maybe dog ear this, or just, if you're on virtual, I don't know how you can do it, but flag it somehow or make a note of it. So for this one, we're going to do the exact same thing we did before. We're going to have our y equals a x minus p squared plus q, and we're going to put in our values for our p and q that we get from the vertex. So it's going to be x minus 0 squared plus 1. Okay. Now we don't know what a is, but we know that this parabola also goes through the point to 9. So this gives us a value where if we put in 2 for x, it will give us 9 for y, because that is the input output for this parabola. So what we can do is we can substitute these values in for x and y and solve for what a has to be in order for this to be a point on the parabola. So I'm going to rewrite this. I'm going to have my y first. Common error of students is because x is always given first, they want to put in the x value for y because they're just reading it left to right because we're so creatures of habit. But you have to remember that the y is the second number given in the coordinate, and you have to put the 9 in for the y. We don't know what a is. That is the whole reason we're doing this. We want to solve for it. The x value we're going to give is a 2. 2 minus 0, I can do that math right now. 2 minus 0 is 2 squared plus 1. So now I'm going to use algebra and solve for a. I'm going to subtract 1 from both sides. I don't know why my color coding is having some issues here. Like it's my color coding's fault. All right, so 9 minus 1 is 8 equals a, and now 2 squared, we've got to do this first, 2 squared is 4. So we have a times 4, or 4a. It kind of looks a bit backwards, and I could have written it out the other way, but it doesn't really matter. So now I'm going to divide both sides by 4, and we get that a equals 8 divided by 4, which is 2. Now I switched my left and right side. That's just arbitrary. You can leave it on the right side. I really like it to be on the left side. I'm a very particular person. All right, so let's try, I want you to pause the video here and try the next one. Okay, so we have y equals a x minus p squared plus q. Again, we're going to use the vertex to put in our p and q values. So it's going to be y equals a, x minus negative 2 becomes x plus 2 squared, and plus q, it'll be plus 4, like that. Now we're going to use negative 4 for x and negative 2 for y, so that we can solve for what value of a has to be for a in order for this to be a point on the parabola. So remembering that for y, we look at the second point, so it's negative 2 equals a times x, so x is negative 4, plus 2 squared plus 4. And now we're going to simplify those brackets. We're going to get negative 2 equals a times negative 4 plus 2 is negative 2. Negative 2 squared is 4 plus 4. And now we're going to, now that we've simplified as much as we can on the right side, we're now going to use algebra to isolate a. So we're going to subtract 4 from both sides. We're going to get negative 6 equals, and I'm going to switch the 4 and the a around because best practice is always to write your number first as the coefficient. Just helps avoid other problems. And now I have negative 6 equals 4a. I'm going to divide both sides by 4. And I'm going to get a equals negative 6 over 4, which is the same thing as negative 3 over 2. So now I figured out a, and I actually forgot to do this on the last one. Now I have to write out the full equation. So I figured out what a is, and I already had the almost equation up here. So now I'm just going to rewrite that equation, and now that I know what a is, I'm going to put a in, negative 3 over 2 in for a. So it's going to be y equals negative 3 over 2 x plus 2 squared plus 4. So here is my full equation. Now to test it out, I could then put in a negative 4 for x and make sure it equals negative 2, make sure I did my work right. Or I could put in a negative 2 in for y, because I know this is a point, and make sure that I can solve for x being negative 4. Just going back to the previous example, because I forgot to write it out, we had y equals a times x minus 0, which is just x squared plus 1. Now that we know what a is, we can rewrite that full equation out to put the 2 in there like that. Sorry, I forgot to do that in the previous question. Just got so excited finding a, and that I pulled a common mistake and error forgetting to fully answer the question. Don't do that yourself. Okay, so that's how you can find the equation given the vertex and a point. You can also find the equation for a vertex form if you have, oops, I skipped the page, if you have just 2 points that fall on the parabola. If you know it's parabolic and you have 2 points, you can solve for the various different things, A, P, and Q, and you can find the equation. So you need a little bit of information. So this one gave us just P. You could also do it if it just gave you Q, and it gave us these 2 points. Okay. So I'm going to go through how to solve that. So the first thing you're going to do is you're going to use the first point. You don't have to use the first point. You could actually use the second point. You just need to use one of the 2 points given to you. So I'm going to use the first point given to me. It doesn't really matter. And I'm going to put that in for not P and Q because that's not our vertex. So those do not go in those places. But where they do go is in for X and Y. So if I rewrite my equation, the y equals a times x minus p squared plus q, and put in this in for x and this in for y, I'm going to get 5 equals a -2 minus 2, because that minus 2, of course, was given to us, squared plus q. And now I'm going to simplify as much as possible. So I'm going to get 5 equals a times -4 squared plus q. And this is going to give me 5. I don't know why it does that. It's so annoying. 5 equals -4 squared is 16. So it's going to give me 16a plus q. So what I want to do is I actually just want to solve for q. So, because it's easier to solve for than a, because a I'd have to divide by 16 at the last step, but q is kind of just hanging out by itself. So that's what I'm going to solve for. I'm going to subtract 16a from both sides. And I'm going to get 5 minus 16a. I'm going to rewrite that actually. I'm going to rewrite that. I don't know why, I want to. Is -16a plus 5 equals q. So that's the same thing as saying q equals -16a plus 5. Again, the left and the right sides arbitrary. You can switch them back and forth as much as you want. Okay, so now I have a new relationship that I figured out. I figured out what q is in terms of a. So the next thing I'm going to do is I'm going to sub in q for q in my original equation, and I'm going to sub in what I found that q is equal to. So I have only one variable. So I'm going to substitute q equals -16a plus 5. There's like an extra little dash there, and it's just okay. So if I have y equals a x minus 2 squared plus q as the equation given to me, like up here, and I know that q is equal to -16 plus 5, that means that I can substitute this q, I can substitute it out and substitute in that -16. So I'm going to rewrite this equation, but instead of writing q, I'm going to write -16a plus 5. So now I have a whole bunch of stuff, but I can't really go any further because I still have an x, a y, and an a, but I was given a second point. So what I'm going to do here is I'm going to use the second point, which was for -1, and I'm going to substitute these values in. So I'm going to substitute this x value in for this x and this y value for this y, because this point also exists on the parabola. So I only have things in terms of a, and I can solve for what a has to be in order for this to be true. So, or in order for this point to exist on the parabola. So I'm going to have -1 equals a times positive 4 minus 2 squared minus 16a plus 5. Okay, so that negative 16a plus 5 ensures that this parabola also will fit that first point that we had on it. Okay, so from here we're now simplifying and going to use some algebra to isolate. So negative 1 equals a times 4 minus 2 is 2. 2 squared is 4 minus 16a plus 5. So negative 1 equals, we have 4a, so I could have rewritten this as 4a, and I'm subtracting 16a, so I have a total of negative 12a plus 5. I'm now going to subtract 5 from both sides, so I get negative 6 equals negative 12a. Then I'm going to divide by negative 12. And I'm going to get that a equals positive 6 over 12, which is the same thing as a positive 1/2. So now I have what my a equals. I already know what my p equals because it was given to me. The last thing I have to do is figure out, well, what's q? And conveniently, I already have an equation that's isolated for q. Q equals negative 16a plus 5. I'm going to substitute my newfound value for a, which is positive 1/2, and solve for q. So negative 16 times 1/2 is the same thing as multiplying 16 by 0.5 or dividing it by 2. It's negative 8. So q is going to equal negative 3. So now I have my q value. I have my a value, and I was already given my p value. So now I can write my final equation where y equals a, which is 1/2, x minus p, which was given to me as 2, plus q, so plus negative 3, which is minus 3. And here is my equation. I should be able to put either of those x values of the 2 points given to me and get their corresponding y values as a check. All right, the last thing that we're going to do is talk about just how you can find the axis of symmetry. Remember, the axis of symmetry is actually the x coordinate of the vertex. So if you looked at a Cartesian plane here, and we did this following one out, I'm going to show you what I mean. So this says the x-intercepts of a parabola are 5 and negative 7. So 1, 2, 3, 4, 5. Here's one x-intercept, and negative 7. 1, 2, 3, 4, 5, 6, 7. There's negative 7. Now, the axis of symmetry is directly in the middle of the parabola. It means that the 1/2 will look like the other half if you actually were to draw that line. The axis of symmetry goes directly through the vertex because the vertex is the point of which it goes either way. So if you can find out halfway between 5 and negative 7, you can find the axis of symmetry. So if we're going to do this with graphing, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points between these two axes of symmetry, these two x-intercepts, which means halfway would be 6. So 1, 2, 3, 4, 5, 6. So here is the axis of symmetry. We don't know anything else about this parabola, so we don't know if the axis of symmetry is above or below the axis, the x-axis. We don't know that stuff, but we know it's somewhere on that green dotted line. We know also that it was 6 this way and 6 this way, and from the graph we can tell that this occurs when x equals negative 1. But as you can imagine, that sometimes is really hard to find by graphing. What if the two x-axis or two x-intercepts were irrational numbers? what if they were, you know, negative 3,266 and positive 522? That you don't want to be sitting there counting dash marks out. There must be a faster way to find it, and there is. So to find the axis of symmetry when you're given two x-intercepts is you take your two x-intercepts, you add them together, and then because you're trying to find the middle point, you're going to average them, which means you're going to divide by 2. So 5 plus negative 7 is negative 2. Negative 2 divided by positive 2 is negative 1. And ooh, look at that. We got the same thing. So the 2 points that you're given to find the axis of symmetry do not actually have to be the two x-intercepts. They just have to be directly opposite each other on the parabola. And how you can tell that from a point given is that they'll have the same y value. So for this next example, it's given us 2 coordinate points. They're not x-intercepts, but we can still find the axis of symmetry, which means we can still find the p-value for the vertex form, and we can still find the x-coordinate portion of the vertex. We do the exact same thing. What we're going to do is take the two x values of these corresponding points that are directly across from each other on the parabola. We're going to add them together, and we're going to divide by 2. So here the axis of symmetry is x equals negative 3. Okay. So what I would like you guys to do is try these questions in the textbook. Let me know if you have any questions. I hope that was helpful, and I hope you guys are all doing well.